Dear students, in this video, now we will learn a very important reaction in the chapter of chemistry of amines, that is Carbyl-amine reaction. This reaction is very important in synthetic chemistry also, because this is one of the synthesis of isocyanides, and it also very frequently used in identification of primary amines, and it differentiates primary amines from secondary and tertiary amines. So now we will see how this reaction works. So this carbylamine reaction, this reaction is also known as Hofmann isocyanide synthesis. As I explained earlier, that this reaction is one of the key reaction for synthesis of isocyanides. So due to this reason, it is known as Hofmann isocyanide synthesis, because reported by Hofmann. This reaction involves the use of primary amine, the chloroform, and a strong base, usually the alkalis NaOH or KOH, and it leads to the conversion involve the intermediacy of dichlorocarbene. In this reaction, dichlorocarbene forms as an intermediate. This is another important question which frequently asks in your examination, that which of the reaction involves the dichlorocarbene as an intermediate. So this is carbylamine reaction. The synthesis of tertiary butyl isocyanide from tertiary butylamine in presence of catalytic amount of phase transfer catalyst also is an example, and the PTC of phase transfer catalyst is benzyl triethyl ammonium chloride. This reaction is very useful in synthetic organic chemistry, as I told. The primary amines undergoes this reaction very readily, but secondary and tertiary amine does not show this reaction. Due to this reason, this reaction is used in practical chemistry to identify the primary amines, and in this context this reaction is known as Sidzeff isocyanide test. So as you can see here, in this reaction involves primary amine CnH2, chloroform, and a base, which leads to the formation of isocyanide and removal of sodium chloride and water. And students, this isocyanide has very foul smell, very intense foul smell. Even a drop of isocyanide spilled in laboratory will force everyone to evacuate the lab. So even a drop, so you can imagine how intense smell of isocyanide is, and this is due to this smell we can easily identify the formation of isocyanide. So this carbylamine, here you can see this is aniline, this is chloroform and KOH. When these three reactants heated, they form the isocyanide, and potassium chloride and water is eliminated. Now we will see the mechanism. Its mechanism involves the addition of amine to dichlorocarbene, a reactive intermediate generated by the dehydrogenation of chloroform. So two successive base mediated dichlorination step results in the formation of isocyanide. We will see how. Here you can see that here is the dichlorocarbene. So this dichlorocarbene is generated from chloroform. We have the chloroform, and by the action of base it generates a dichlorocarbene. Since dichlorocarbene is electron deficient species, so it reacts with the lone pair of aniline, lone pair present on the nitrogen of aniline, and dichlorocarbene adds on the nitrogen of aniline. Now again it eliminates one hydrogen chloride molecule, which leads to the formation of another intermediate, which is shown in the blue. You can see this intermediate in blue is formed by elimination of hydrogen chloride, the Cl- and H+. And again from this intermediate one hydrogen chloride molecule eliminates, which leads to the formation of isocyanide. Here you can see this isocyanide can exist as the resonating structures of two structures. They are shown here. In one structure we have the negative charge on the carbon and positive charge on the nitrogen atom. So as I told that carbylamine reaction is a characteristic reaction given by the primary amine. So due to this reason, this reaction for primary amine makes it useful tool for identification of primary amine. We can differentiate primary amine from the secondary and tertiary. This is the practical importance of this carbylamine reaction. So this is all for carbylamine reaction, and in next video we will see another important reaction. So thank you.